Let's start our discussion of z-scores with an example. Suppose you take exams in two of your classes. You've got Class A and Class B. You take an exam in each, and suppose that in Class A, the average is 60, the mean is 60, with a standard deviation of 5. And you score, say you score a 68. All right, so your score, X, is a 68. Now, you did score above the mean. 8 points above the mean. Now, suppose in Class B, the average score there, the mean score was 82 with a standard deviation of 9. And remember what the standard deviation does. It measures how spread out the data is. So in Class B, the average was 82, the standard deviation was 9, and suppose your score, X, we'll call it, is 90. So suppose you scored a 90 in that class. So in Class B, you also scored above the mean, right? You scored above the mean in Class A, 8 points above the mean, and in Class B, well, you also scored, 8 points above the mean. But here's the question. Relative to each one of your classes, in which class did you do better, right? In which class did you actually score higher? Well, we're going to answer that question by taking a look at z-scores. Now, here's what a z-score is. A z-score is a measurement, a statistical measurement, of a score's relationship to the mean. Another way of saying this is a z-score tells us how many standard deviations a given value is away from the mean, right? So, like back in our example, I got a given value, 68. How many standard deviations is this away from 60? And this one down here, 90. How many standard deviations is 90 away from the mean? So here's our formula. See if we can make sense out of it as we write this. So the z-score is, now I want to know how many standard deviations a value is away from another value. So like in our example here, how many units or how many standard deviations is 68 from 60? So first of all, how far is 68 from 60? Or down here, how far is 90 from 82? Okay, I can find that by just computing the difference, right? X minus X bar. Now when you make a subtraction tells you what the difference between two numbers is. So what I'm doing here is I'm just finding the difference between two numbers. So I use the subtraction. But now I want to know not just the number of units. Like this would be maybe, what would this be? Say down here in this one. This would be 90 units, or 90 points minus 82 points. That's 8 points. Okay, that just tells me that these two numbers are 8 points apart. How many standard deviations is that 8 points? So I'm going to divide by 9 to find out how many times 9 would go in there. Or in this case, here's an 8-point difference. How many of those 5s would go in there? That tells me how many standard deviations go into those 8 points. So what I'm going to do is I'm going to divide by S. This is our formula for the z-score. So let's compute these for both of our values, both of our classes. All right, so for Class A, how about our z-score? I'll put a z sub A to keep track of these. The z-score for Class A, it's a fraction. Okay, I'm going to write the formula, X minus X bar over S. I just got into the habit of every time there's a formula, I write that formula, so it's like I have a roadmap right in front of me, and all I have to do is fill in the numbers. So X, all right, this is Class A. So that was a 68, and then minus the X bar, which is 60. So we're going to get 68 minus 60 all over S, right? All over S, and S is 5. All right, that's 8 over 5, which turns out to be 1.6. Now, that tells me this. Okay, let's get some room here. In Class A, we scored 1.6 standard deviations above the mean. All right, so we scored above the mean. How far? 1.6 standard deviations. Now, what about in Class B? Well, in Class B, let's call it Z sub B. We're going to have, all right, X minus X bar over S. That's going to give us 90 minus 82 over what, 9 in this case? That's going to be 8 over 9, which is okay, 8888. How about 0.9? Okay, that's 0.9. All right, we'll get some bit of stuff at the top and we'll write a conclusion here. In Class B, we scored 0.9 standard deviations above the mean. All right, so in Class A, just to show it here, Class A we scored how far? 1.6 above the mean. In Class B, we scored only 0.9 above the mean. So in which class did we do better? We did better in Class A because we were higher above the mean. All right, so what we've done here is we can use the Z-score to kind of compare two different things, right? In this case, just two different classes. So the Z-score, this is a measure of position. It measures how far above or below the mean we are in terms of standard deviations.